Okay, for this week's lessons, we're going to be doing Unit 6, Lessons 5, 6, and 7, which continue our work with problem-solving skills, but with a focus on comparisons, when you're comparing numbers in order to problem solve, or when a problem-solving question asks you to compare two amounts. There are two types of comparisons. Additive comparisons, in which you have to add or subtract in order to compare the numbers, or multiplicative comparisons, in which you have to multiply or divide in order to compare them. Additive, the root word is add, so we have addition and its inverse of subtraction. Multiplicative, the root word is multiple, so we have multiplication and its inverse of division. So these are skills you already have. It's now just using these vocabulary words in order to identify them and make our problem solving a little more sophisticated. So starting here, just scoot this so that we can. All right. So our directions say, in comparison problems, you compare or figure out the relationship between two amounts. And it says by addition or by multiplication. So it means the comparison problem can be an additive problem or a multiplicative problem. It says draw comparison bars when needed. So for the first one, we'll show you how to draw comparison bars if that helps your brain. Let's look at number 1. Julia jumped, so it's a jump rope contest to give you some context. I'm going to cube the problem. Julia jumped 1,200 times. Samantha jumped 1,100 times. How many more times did Julia jump? Okay, so we're comparing how much Julia jumped with how much Samantha jumped, and we're solving for how many more times did Julia jump. So my label is more times. In order to compare these, I need to find the difference. So this is an additive comparison problem because I have, here is what Julia jumped. I'll put a J for Julia. Here is what Samantha jumped. Oop, I meant to put a 1 here. And we want to find the difference between them. So in order to do this, we have to subtract. You can pause and do this and then check your answer. So it's 1,200 minus 1,100. You might be able to do that in your head, but it's always important to show your work, especially if it asks you to. So Julia jumped 100 more times. Let's look at the next one. Ahanu jumped 1,050 times. Rolando jumped 1,080 times. How many fewer times did Ahanu jump than Rolando? So we're solving for how many fewer times. There's two ways that you can compare things. Say I'm comparing the numbers 5 and 3. One way I could compare 5 and 3 is say 5 is 2 more than 3. Or I can go the other way and say 3 is 2 less than 5. So when we're comparing, you can compare in two different directions, more than or less than. The first one we solved for Julia jumping more than Samantha. Now we want to know how many fewer times Ahanu jumped. Again, you could draw, so Ahanu jumped 1,050, Rolando jumped 1,080, and we want to know the difference. Okay, so how many fewer times did Ahanu jump? So we are going to subtract again. 1080 minus 1050. Show you work. So Ahanu jumped 30 fewer times. You could have also, if it was asking how many more times did Rolando jump, then it would have been 30 more times. Okay, it's important to figure out what you're solving for. Okay. Let's look down here. Let's look at number 4. Or number 5, I'm sorry. Ted jumped 1,300 times. He jumped 100 more times than Mario. How many times did Mario jump? So we are solving for how many times Mario jumped. Ted jumped 1,300 times. Mario jumped 100 times fewer than that. Okay, so we don't know what Mario jumped, but we know it's minus 100 because it's 100 times fewer. So in order to solve it, we have to do 1,300 minus 100. Again, you might be able to do that in your head. So Mario jumped 1,200 times. On this one, we don't need more or less because it's just asking how many times he jumped. Let's continue on now. Okay. Let's see. One moment, please. For this one, we will practice writing our equations. So let's look at number 8. Again, pause and do these along with me if you can. Ty scored 6 points in a basketball game. Ed scored 4 times. Oops, I'm supposed to circle that. Ed scored 4 times as many points as Ty. How many points did Ed score? So we're solving for how many points Ed scored. So I'm going to write it as a sentence. Ed scored, I'm going to leave a blank and write points. So Ty scored 6 points. Ed scored 4 times as many points. So the first thing you should think is who scored more? What number needs to be higher? We're solving for how many points Ed scored. So for my solution equation, I'm going to use P as my variable because P stands for points. So I'm now going to take what Ty scored, which was 6, and since Ed scored 4 times as many, I'm going to multiply it by 4. 6 times 4, so my amount of points would be 24. So Ed scored 24 points. Let's do, so this one, because it says times as many, that is a multiplicative comparison because you were asking how many times more or how much you had to multiply it by in order to get to the next amount. And you multiplied in order to solve it. So this was multiplicative. Here it was additive because we were just talking more or less and you used addition or subtraction to do your answer and check your answer. Here, if I wanted to work backwards, so I did multiplication. If I wanted to check it, I would check it with addition. So it's a multiplicative one. Let's do one more. Let's do number 12 so we get practice with a fraction. Chester has 49 files of music downloads. Tony has 1/7 as many as Chester. How many files of music downloads does Tony have? I'm going to write Tony has, so I know I'm solving for what Tony has. Okay, Chester has 49 files of music. Tony has 1/7 as many. So he has a fraction of what Chester has. So think about who needs to have more. I'm solving for music downloads, so I'm going to use M as my variable. So M equals, how do I solve this? What is my solution equation? Well, Tony has 1/7 of 49. So M equals 1/7 of, means multiply, 49. Because this said times as many, or 1/7 as many as, it's multiplicative. As usually tells you that it's multiplicative. So then you solve. Pause and solve. So Tony has 7 music files because 1/7 of 49 is 7. Very good. Lesson 6 has us looking at how to model and solve comparison problems. So it says the model, or math drawing, below represents the time a student worked on spelling, S, and math, M, homework. When it gives you a letter in parentheses, it's giving you the variable to use for what you don't know. So if it tells you to use S, do not use the variable N. Use what it tells you to use. So the model below represents the amount of time a student worked on spelling, S, and math, M, homework. Use the model to solve problems 1 through 3. So, write a comparison sentence that includes the word as long as. Okay. So, it says M to S. So that means I am comparing M to S. So I'm starting with M. So M is, and I need to use the words as long as. So how many times as long as S is it? Let's see. This is 1. Here we have 1, 2, 3, 4, 5, 6, 7. So M is 7 times as long as S. That line was way too short. Because you see, M is 7 times longer. There's 1 here and there's 7 here. Now we can compare in the opposite way. Compare S to M. So it wants us to start with S. S is, you cannot write the same thing because S is not 7 times as long as M. S is smaller. So you have to use the inverse. So if M is 7 times longer than S, then S is 1/7 as long as M. Because S is 1 out of 7 pieces, compared to M, that is 7 out of 7 pieces. Okay? So if we were comparing these two again, M is 7 times as long as S. S is 1/7 as long as M. Write a comparison equation. Remember, the difference between an equation and an expression is that an equation has an equal sign that compares M to S. I don't want you to be too confused. So what it wants us to do is write an equation showing how we could solve for M using what we know about the size of these bars. So M is equal to S times what? Well, M is 7, S is 1, So m is equal to 1, or s, times 7. The other way this lesson wants you to understand that you can write multiplication is like this. When a number and a variable, or a number and a letter, are right next to each other like this, it means multiply. So that's a fancy 5th grade thing that you've learned now. If you don't have the multiplication sign, but the letter and the number are right next to each other, that means multiply. Now it wants us to compare the other way. S equals, well, how would we solve for S using what we know about m? Well, s is equal to 1/7 of, which means multiply, m. And then the other way you could write that, using your understanding of where you can place the number and the letter, s equals 1/7 m. It looks very fancy and very complicated, but it's the same problem solving that you've been doing. It's just now we're taking the time to learn these other steps and other ways to write it. And then lastly, because multiplication and division are inverse operations, they undo one another, you could also write a division equation that compares s to m. So by saying s equals, how could we solve for m? Well, s could equal m divided by 7. M divided by 7. So if I wanted to solve for s up here, I could take m, so I could take 7 and divide it by 7, which would equal 1. The other way you could write this, kind of like with multiplication, there's another fancy way that you can write division. You could write s equals m over 7. Because remember, a fraction like this, the fraction bar just means divide. So here, you learned some fancier ways to write equations. Okay? Let's move on. Actually, no, I want to do this one down here. Let's do number 4. It says solve, draw a model if you need to. I want you to please draw a model. So pause and solve this as I am and draw a model. The length of an unstretched spring is 120 centimeters. How long, L, it gives us the variable, so that's what we have to use, will the spring be if it is stretched 3 times that length? So, if I take, I'm going to use, for my model, I'm going to say this is when it's unstretched. I'm using a U, and I'm saying this is when it's unstretched. It's 120. And then when I stretch it, it's going to be 3 times that length. So 1, 2, 3. So this is that L that I'm solving for. The length of an unstretched spring is 120 centimeters. Unstretched, it's 120. How long, L, how long will that string be if it's stretched 3 times that length? So 3 times 120. Our solution equation would then be L equals 120 times 3. You could also write it as 3 times 120 because of the commutative property. And then I want you to solve and tell me what L equals. And our label is centimeters. Go ahead. So 3 times 120 is 360. Great work. And finally, in lesson 7, it has us determine whether a problem is additive or multiplicative. So it says for each problem, draw a model and write additive comparison or multiplicative comparison to identify the type of comparison. Then write an equation to solve the answer. An additive equation is when something is more or less, and you have to add or subtract to understand how they compare. Multiplicative comparison is when something is as many times as, or as many times fewer as, and you have to use multiplication or division to solve. So let's start with the first one. A newborn baby, Lila, is 44.5 or 44 5/10 centimeters tall. Her brother, Tremaine, is 4 times as tall. How tall, T, is Tremaine? It's very important that you use the variable that they give you. So we're looking for how tall Tremaine is. Here is your keyword, times as tall. Times as means multiplicative. So this is an multiplicative comparison. So what we could say is, okay, so newborn baby, why don't we use Lila? We'll use L for Lila. Lila here is 44.5 centimeters tall. Tremaine is 4 times as tall. So here we have 1 time, 2 times, 3 times, 4 times, and this amount that we don't know yet is what we're solving for, which is T. So how do you solve this? Well, we're multiplying something times 4. So our equation would be, our solution equation would be T equals, because it told us to use T, 44 5/10 times 4. You could have also written that the other way. Pause and solve. I am out of room. So I'm going to write T equals 178 centimeters. So Tremaine is 170 centimeters tall. The way I did this was I multiplied like normal and then adjusted my decimal at the end. Let's look at number 3 because, to be honest, I just don't feel like I have enough room to do number 2. So Imani completed a 200-meter race in 25 6/100 seconds. Talia completed the same race in 1 1/1700 fewer seconds. How long, S, did it take Talia to complete the race? I'm going to draw a model for us here. So I circled this 200, but that's just a detail about this situation. That's not a number I'm going to need. So Imani, I'm going to use I for Imani, and she completed the race in 26. Just put it like that. She completed the race in 26 6/100 seconds. Talia completed the race in 1 1/1700 seconds fewer. So Talia, I don't know what she completed it in. That's that S that I'm solving for. But I know that it's 1.17 less. So how do I solve this? This is an additive comparison. because Talia's time plus 1.17 equals 25.06. So additive, I'm using addition or subtraction to solve. My equation to solve for S would be S equals what Amani ran, 25.06, minus the difference between the two, which was 1.17. And then it'll tell us how many seconds it took Talia to complete the race. This didn't ask for as many times as, didn't ask for that. It told us the difference, and we had to take away that difference in order to solve it. So when you set up your numbers and you line up your place values and you subtract, you should have gotten 23 and 89 hundredths seconds. It's very important that in track they measure time as far out as they can or as accurately as possible by going as many place values this way, because when you look at this, it doesn't seem like it was that far off. It seems pretty close, but as you can tell, it does make a difference in the timing of the two girls' runnings. So, additive, you add or subtract in order to solve it. Multiplicative usually has the word as times, as many times as, and you have to multiply or divide in order to solve.